Hello, I'm Mr. Howard. In this video we are going to do a Unit 1 review. This is for my pre-cal students. I'm going to work 6 examples from your review, or 6 problems from your review, and I'm picking the ones that I've seen my students have the most trouble with. So we're going to work a few factoring patterns, and then the rest will be rational expressions, both multiplying and adding. Alright, so let's look at this first one. We're asked to factor 5x squared minus 45. Well, the first thing we always look for is a greatest common factor. And we can see we can factor a 5 out of this term and a 5 out of this term. So we're going to do that first. So we have 5 and we're left with x squared. So we divide 5x squared by 5. So 5x squared divided by 5 is just x squared. We divide negative 45 by 5, and that is minus 9. Okay, and then we see a pattern here. We have difference of two squares. Remember that when you have a squared minus b squared, that pattern becomes a plus b, a minus b. Okay? So that's what this is going to be. So this is going to factor to the square root of this one is x, square root of this one is 3, so it's x plus 3, x minus 3, with the 5 out in front. X plus 3, x minus 3. Okay, so that one is done, and we will move on to the next example. Alright, the next one we're asked to factor again. We see a cubed term here, so we're immediately thinking either difference of cubes or sum of cubes. We are subtracting here, so that's difference of cubes. You've got your sheet that I put up on the website, and also in your notes as far as the patterns go. So the difference of two cubes, the a cubed minus b cubed, which is the form this is in right here, is equal to a minus b times a squared plus ab, whoops, no parentheses yet, plus b squared. Okay, so we just identify our a and our b. So a is the cubed root of this whole thing. So the cubed root of 8 is 2. So my a is 2, and then the cubed root of x cubed is just x. So my a is equal to 2x. So everywhere I see a, I'm plugging in 2x into this pattern right here. My b value is the cubed root of this term. So the cubed root of 27 is 3. So everywhere I see a b up here, I'm plugging in a 3. So my final answer is going to be 2x minus 3, just a minus b, this minus this. Alright, and then I've got a squared here, so I need to square this whole thing. Square the whole thing, so that means 2x times 2x, which gives me 4x squared. It's going right there. Plus this times this, so 3 times 2x is 6x. Plus this term, we've got b squared, so this term squared, 3 squared is 9. Okay, so final answer, 2x minus 3 times the quantity 4x squared plus 6x plus 9, and that one's done. Okay, let's move to the next example. Alright, this one we're asked to simplify. We've got two rational expressions. There's no sign between them, so we're multiplying. There's an implied multiplication. A common mistake that I saw in this unit is students, even though they're multiplying or dividing rational expressions, they were trying to set up a common denominator. You don't need to do that. You only do that when you're adding or subtracting. So here we're just multiplying. The first thing that we do is always factor. So this one right here, I'm going to factor off to the side. That will factor, and then also this one right here in orange will factor. So let's do that off to the side. So x squared minus 16, that's a pattern. Difference of two squares. This term has a perfect square root. This term has a perfect square root. We're subtracting them, so we're thinking difference of two squares. So all we do is we write two sets of parentheses. Square root of this one is x. It goes here and here. Square root of 16 is 4. It goes here and here. And then we just add them in one parentheses and subtract them in another. Okay, so that's how that one factors. Now let's look at this part. So we've got x squared plus 10x plus 24. We have a leading coefficient of this trinomial is in this trinomial, the leading coefficient of the x squared term is 1. So now I just look for two numbers that will multiply to 24 and add to 10. So off to the side here we can write factors of 24. So 1 and 24. Okay, that multiplies to 24, but it'll add to either 25 or 23 depending on how the signs are set up. Next would be 2 and 12. Multiplies to 24 but would combine to either 14 or 10 depending on how the signs are set up. Next would be 3 and 8. Multiplies to 24 but would combine to either 5 or 11 depending on how the signs are set up. So next would be 4 and 6. Multiplies to 24 and that would give us 10 if they're both positive, or it could give us 2 depending on how the signs are set up. So 10 or 2. We want 10, so we want this to be plus plus. So a plus here, so that's just going to be x plus 4, x plus 6 is how the orange part factors. So let's write that all out. So now that I've factored it, I'm just going to rewrite this thing with everything factored that will factor. So we have x plus 4, x minus 4 over x minus 3 times the 2x minus 6 over, and you know what? I need to factor that one too, don't I? Look, this one has the greatest common factor, so let's do that. I'm going to erase this. Should have done that to begin with. Okay, 2x minus 6 has the greatest common factor of 2, so that becomes x minus 3. Okay, so 2x minus 6, you're dividing this term by 2, dividing this term by 2, and that gives me 2 times the quantity x minus 3. Okay, and then the orange part right here, x squared plus 10x plus 24 factored to x plus 4, x plus 6. Okay, so now we just start canceling. So I can cancel x minus 3 with x minus 3. I can cancel x plus 4 with x plus 4. And now I'm just left with what's on top is 2 times the quantity x minus 4. So 2 times x is 2x. 2 times negative 4 is negative 8 over just x plus 6 on bottom. Okay. It wouldn't be wrong to go ahead and leave this factored and just do this is equivalent to 2 times the quantity x minus 4 over x plus 6. Just multiplying this times this whole thing. Either way works. Really, this is more factored, so probably would prefer this answer right here. Okay, so that one's done. Let's move to a different problem here. Alright, this next example here, this would be number 6 on your homework. We are adding two rational expressions, so we need to factor everything that we can first and then set up a common denominator and then add them. When you add fractions, remember you have to add or subtract fractions. You have to have a common denominator. So let's set that up. So this one will factor, x cubed minus 1, that will factor. This one you might think would factor, but it actually won't, because our leading coefficient is 1, so we would have to have two numbers that would multiply to positive 1 and add to positive 1, and there isn't anything that would do that. To multiply to positive 1, we could have 1 times 1, which would add to 2, or negative 1 times negative 1, which would multiply to 1 as we need, but would add to negative 2. So this will not factor. This will not factor at all. This one will factor, so we'll work on that off to the side. Okay, so this in the orange, let's factor that. So x cubed minus 1, we see a cubed term here, so we're immediately thinking sum of two cubes or difference of two cubes, and we're subtracting, so it's difference of two cubes. That means that when it's in the form a cubed minus b cubed, it factors, which this is in a cubed minus b cubed. This has a perfect cubed root, this has a perfect cubed root, so we can apply this pattern. So that's equal to a minus b times the quantity a squared plus ab plus b squared. That's in your factoring patterns. Okay, so everywhere I see In A, I'm going to plug my A value for this in. Everywhere I see a B, I'm going to plug my B value in. So my A value is simply equal to the cubed root of this term. So cubed root of x cubed is just x. My B is equal to the cubed root of this term. Cubed root of 1 is just 1. So everywhere I see an A here, I'm plugging in x. Everywhere I see a B, I'm plugging in 1. So my answer would be, or my factoring would be, x minus 1, x squared, plus 1 times x is 1x, plus this term squared would be just 1. 1 squared is just 1. Okay, so that's how that part factors. Now let's look at the part in blue. Okay, the first thing we always look for is greatest common factor. We have that, so that would be 2. We can divide 2 out of this term, out of this term, and out of this term. So when we divide 2 out of those, we end with x squared plus 9x minus 10. Alright, so the next thing that we look for is try to see if this one will actually factor. So we need two things that would multiply to negative 10. We have a leading coefficient of 1. So two numbers that would multiply to negative 10 and combine to positive 9. So that'll work. 10 and 1. 10 and 1 with the 10 being positive. So this would then factor, we can't forget the 2 out in front, but this would factor to x plus 10, x minus 1. So now it's fully factored. Okay, so we're just going to rewrite this whole thing with each component fully factored that will factor. So that gives us a minus b. Wow. Let me back up there. Hold on. It actually gives us, let me fix that, x minus 1 x minus 1 x squared plus x plus 1. So that's this part factored, which we have right here. Okay, over x squared plus x plus 1. Remember, this wouldn't factor. Plus 16 over this thing factored to this right here, 2x plus 10 x minus 1. Okay, now we simplify as much as we can. So notice this is nice. This cancels and that cancels. This and this we can simplify that. This becomes an 8 and this just falls off. So let's rewrite that again. We have x minus 1 left over here, basically over 1 now because these two canceled, plus 8 over x plus 10, x minus 1. Okay, so now to get a common denominator between these two. Alright, well that's pretty simple because this denominator is 1 and this is x plus 10, the quantity x plus 10 times the quantity x minus 1. So we just need a common denominator of this right here, x plus 10 times x minus 1. So that means we just multiply this term by x plus 10 over x minus 1, x plus 10 times x minus 1 over x plus 10 times x minus 1. So we're going to multiply this by x plus 10, x minus 1, I'm trying to write small here so it'll fit, over x plus 10 times x minus 1. That establishes our common denominator for us on the bottom. So our common denominator is going to be x plus 10, x minus 1 on bottom. And now we need to multiply these two. So to make this simple, we're going to leave this x plus 10, and then x minus 1 times x minus 1 is just x minus 1 quantity squared. And then we've got plus 8 left here. Okay? So that is actually all we can do. That's as simplified as it gets. You cannot cancel this x minus 1 with this x minus 1 because you have an addition over here. So if you cancel this out, it has to be with every single term, and every single term in this numerator does not have an x minus 1. So we're going to stop right here. This is our final answer. We can't do any more than that. You could leave this x plus 10 times x minus 1 times x minus 1 plus 8 over this, but to simplify it, when you have two x minus 1's multiplied together, x minus 1 quantity squared is better. So that would be the answer. So that one is fairly complicated, and even when you simplify it as much as you can down to this, it's still not very simple, right? But that's all you can do. We can't do any more than that. Alright, let's move to the next problem. Alright, this will be the last example we're going to work, and this is problem 7 from your review. I know these gave my students a lot of trouble, so I'm going to work this two different ways. The first method I will work with the denominator by itself just to get rid of this addition. I'm going to go ahead and add these two rational expressions that are in the denominator and make them into one, so that I can then divide this numerator 5 over x minus 5 by whatever this becomes. Okay? So that's method 1. In method 2, I'll show you another way where we just get rid of the fractions in both the numerator and denominator and work with them from there. So, but method 1, I'm just going to work with the bottom first. So the bottom, the denominator, is going to, instead of being, right now it's 7 over 2x plus, x plus 1, and then I'm going to factor this one. This one will factor. I always need to do that. So that's x plus 5, x minus 5. So I'm just going to add the bottom first to make it into one fraction so that it's easier to work with. Okay? So when I'm adding fractions, remember I have to have a common denominator. Well, this denominator is 2x. There is no way to make 2x look like this denominator, x plus 5, x minus 5. And there's no way to make this denominator, x plus 5, x minus 5, look like this one, 2x. So the only thing I can do is multiply this term by x plus 5, x minus 5 over x plus 5, x minus 5. And multiply this whole thing by 2x over 2x. That'll establish a common denominator of this multiplied by this whole thing. Okay, so let's do that. Hopefully when I write it out it'll make more sense. Okay, so I'm multiplying this one by x plus 5, x minus 5 over x plus 5, x minus 5. That's just equal to 1, so it's okay to do. Alright, and then that's plus x plus 1 over x plus 5, x minus 5. I'm multiplying this one by 2x over 2x. 2x over 2x is just equal to 1, so that's okay to do. Okay, that establishes my common denominator of this one times all of this. Okay, in both cases. So that gives me a common denominator on bottom of 2x, x plus 5, x minus 5. Okay, now I just multiply this times this, and this times this. Okay, this is one quantity, so I'll have to actually distribute that 2x in twice. Okay, to make this easier, and you'll see why in a minute, I'm going to convert this x plus 5, x minus 5 back to what it was originally, this x squared minus 25. Okay, so that would give me 7 times x squared minus 25. Okay, that's just this part right here. Plus 2x times x is 2x squared. 2x times 1 is 2x. Okay, the reason that I did this is 7 times x squared and 7 times negative 25 is much easier than trying to multiply 7 times x plus 5, x minus 5. Okay, we're still going to get the same answer, but this just made it a little easier to work with. So that becomes 7 over x squared minus 175 plus 2x squared plus 2x. And I'll tell you now, this is not an easy problem. Alright, all over 2x times x plus 5, x minus 5. Okay, we're going to combine like terms here. So 7x squared plus 2x squared is 9x squared plus 2x minus 175. All over our common denominator, 2x, x plus 5, x minus 5. Okay? So that we have simplified the bottom. We have only simplified the bottom into one fraction now. So now we can divide we can go right back up here, and we have replaced this right here. We have replaced that with this. That's all we've done. So now we can rewrite the problem as 5 over x minus 5. I'm going to write it to the side so it's easier to see. Divided by, instead of divided by this now, we're dividing by this fraction, which is the same as this because we simplified the bottom. Divided by 9x squared plus 2x minus 175 over 2x, let me undo that, 2x, x plus 5, x minus 5, x plus 5, x minus 5. Okay, remember when we divide fractions we just flip and multiply, so that's what I'm going to do next. I'm going to flip this and then multiply it by this. So it's 5 over x minus 5 times, this now comes on top, 2x, x plus 5, x minus 5, over 9x squared plus 2x minus 175. Okay, so now that I'm multiplying, I can look for terms to cancel out. And I have x minus 5 here, I have x minus 5 here, so those go away. So now I'm just left with 5 times 2x times x plus 5. So the easiest thing I can do here is just multiply 5 times 2x. That's easy to do. That gives me 10x. And then I still have the times x plus 5 here. I'm not going to multiply that out because this is more factored than it would be if I multiplied 10x times x and 10x times 5. Okay? So that's the final numerator. And then the denominator, the final denominator is just what's left down here. This canceled out, so we're just left with 9x squared plus 2x minus 175. And that would be our final answer. We can't simplify this anymore. So here's our final answer. So that's method 1. I'm going to work the problem again using another method. And you can choose the one that works best, but we will still end with the same answer. Alright, so let's move on to working it another way. Alright, so here's the same problem again. We worked it this way up here. We ended with this answer. Okay, and the way we worked it is we worked the denominator first and took care of this addition and then did the division. That's what we did first. The way we're going to do it now is we want to find something that we can multiply this piece by and this piece by so that we get rid of all of the fractions. We want to get rid of this fraction, and this fraction. So the way that we do that is we factor everything first. The only piece that'll factor is this right here, this x squared minus 25. So I'm just going to rewrite the problem only with this piece right here factored. So that gives us 5 over x minus 5, and I'm going to write it this way because I think it's easier to see, divided by the quantity, this whole thing, 7 over 2x plus x plus 1 over x plus 5, x minus 5. I'm just factoring. I just factored this part right here. Okay? So we want to get rid of this fraction, and this fraction. So we're looking basically for a common term that we could cancel all this out by. So we need a 2x in it to get rid of it. So we've got to have a 2x in this term that we're going to multiply everything by. We need an x plus 5 because this has an x plus 5. And we need an x minus 5 because this term has an x minus 5 and this has an x minus 5. Okay, so here is what we need to multiply this part by and each of these terms by in order to get rid of all the fractions. Okay, so here is the key part, this right here. Because if I multiply this term by this, I'll get rid of my fraction. If I multiply this term by this, I'll get rid of the fraction. If I multiply this chunk right here, this term, by this, I will get rid of it as a fraction. Okay, so I clear all the fractions when I do this. Alright, so let's do that. So the first thing I'm going to do is multiply this by it. So 5 over x minus 5 times this chunk right here, 2x, x plus 5, x minus 5. Okay, that's going to simplify because I can cancel that out with that, and I'm just left with these two pieces right here. So 5 times 2x is 10x times x plus 5. Okay, that's my numerator. Done. Here's my numerator. Already done. Okay, so this is the top of my fraction now. Okay, I don't have any fractions left. Okay, now next I need to multiply 7 over 2x by this chunk. This whole thing again. 2x, x plus 5, x minus 5. And multiply this thing, x plus 1 over x plus 5, x minus 5, by this chunk, 2x, x plus 5, x minus 5. Okay, when I do that, notice the 2x and the 2x go away, leaving me without a fraction. So remember, before it was easier to work with this thing if we multiplied this back out, which was x squared minus 25. Remember, x plus 5, x minus 5 is equivalent to x squared minus 25. Then I just multiply the 7 times that and the 7 times that, and that simplifies it. So that gives me 7 times x squared is 7x squared, and minus 25 times 7 is minus 175. Okay, and then over here I'm going to work with this part, so that's going to be plus this, whatever this ends up being. Notice that my x plus 5 cancels with that x plus 5, x minus 5 cancels with that x minus 5, and I'm only left with 2x times the quantity x plus 1. Okay, so 2x times x, 2x squared. 2x times 1 is 2x. Combine my like terms and I get 7x squared and 2x squared is 9x squared plus 2x minus 175. And my bottom is now this part, my bottom or my numerator. So stack them. So the top part is 10x, x plus 5. Bottom is this, 9x squared plus 2x minus 175. And I can't simplify it anymore, and that's my final answer. And notice that this matches what we got before. We got the same answer twice. 10x times the quantity x plus 5 over 9x squared plus 2x minus 175. We got it here, and we got it here. 10x times the quantity x plus 5 over 9x squared plus 2x minus 175. So two ways to work it. This way, actually, you see everything that we did. I've got it all listed here. All of the algebra that we did is contained here. And then when we worked it this way, all the algebra is contained here. So really, the second method ended up being a little cleaner. There wasn't quite as much to do as there was with this method, but you can watch both methods and see which way you like best and work them that way. So again, the first method, we just turned the bottom of this complex fraction into one chunk so that we didn't have this addition anymore, and then we divided the two. Whereas in the second method, we just found this common string, this common multiplication here that we could multiply the top by and each term in the bottom by to get rid of all the fractions. And either way, we ended with the same final answer. These are tough. These rational dividing and adding rational expressions are tough. Alright, so that's a wrap on this video. I'll see you in the next video.